Hello, everyone. In this lesson, let's learn about the functions and application of frequency converters. In this lesson, we will study from the aspects of the composition structure and terminal wiring, its application, parameter setting, and panel operation of frequency converter. Through the study of this lesson, I hope that everyone can, according to a practical application case of frequency converter, correctly complete the wiring of the actual frequency converter, correctly complete the parameter setting and panel operation, complete the wiring and power on debugging of the actual PLC device, and experience the application of the frequency converter PLC. It can cultivate scientific thinking and sense of responsibility, and stimulate rigorous attitude and innovative spirit towards engineering and technical problems. The frequency converter controls the running speed of the motor by adjusting the power frequency and voltage. The functions of the frequency converter: 1. Control the rotational speed of the motor. 2. Save energy. 3. Protect the motor. 4. Reduce noise and vibration. 5. Achieve energy saving in soft start. 6. Energy saving through power factor compensation. The frequency converter changes the rotational speed of the AC motor according to the change of working conditions, which can improve the energy utilization efficiency. It is a major technological breakthrough for the energy revolution and new energy technology. Encourage all of you to achieve innovative results through technological innovation and transformation. The working principle of the frequency converter: rectification. Convert the voltage and frequency of the AC power supply into a DC power supply, usually realized by a rectifier bridge circuit. Filtration. Filter the rectified DC power supply to remove the pulsating components in the DC power supply, ensuring the stable operation of the inverter. Inversion. Convert the DC power supply into an adjustable AC power supply through an inverter. The inverter is usually realized by power devices such as IGBTs. Output filtration. Filter the AC power supply output by the inverter to remove the high-frequency components in the output power supply, so as to ensure the normal operation of the motor. Control. Convert the voltage and frequency of the AC power supply into a DC power supply, usually realized by a rectifier bridge circuit. Adjust the output voltage and frequency of the inverter through the control circuit, so as to achieve the speed regulation and control of the motor. The second part is the operation instructions for terminal wiring. The wiring diagram is as shown, which is divided into 3 parts: the main current, the input signal, and the output signal. Preparations before wiring. Check the equipment. Ensure that the appearance of the frequency converter and the motor is not damaged, and there is no looseness or corrosion of the wiring terminals. Check the parameters. According to the equipment nameplate and the instruction manual, check the parameters of the motor such as the rated voltage, current, and frequency to ensure they match the frequency converter. Prepare tools. Prepare suitable tools such as screwdrivers and wrenches, as well as auxiliary tools such as insulating tape and a multimeter. Main circuit wiring. Connect the 3-phase power supply wires to the R, S, and T terminals of the frequency converter respectively, ensuring that the wiring is firm and the phase sequence is correct. Connect the U, V, and W terminals of the motor to the corresponding terminals of the frequency converter respectively, and pay attention that the phase sequence of motor wiring is consistent with that of the power supply. Ground protection. Reliably ground the grounding terminal of the frequency converter, and the grounding resistance should be less than 4 ohms to ensure the safety of the equipment and the operators. Control circuit wiring. According to the control requirements, connect the external control signal wires, such as the start, stop, and frequency setting, etc. Ensure that the control signal wires are routed separately from the main circuit wires to avoid interference. Connect Q0.4 to STF for the forward rotation of the AC motor, pin 9. Connect Q1.6 to STR for the reverse rotation of the AC motor, pin 10. Connect Q0.5 to RL for low speed, pin 2. Connect Q0.6 to RW for medium speed, pin 3. Connect Q1.0 to MRS for output stop, pin 5. Connect OV to the common terminal, pin 12. Inspection after wiring. Appearance inspection. Check whether all the wiring is firm, whether there is looseness or poor contact, and ensure that there are no exposed wires at the wiring terminals. Inspection before power on. Before powering on, use a multimeter to check the resistance value between each wiring terminal to ensure there is no short circuit or open circuit. Check whether the voltage level of the control signal wire meets the requirements. Power on test. After powering on, observe the display and operation status of the frequency converter, and check whether the running direction of the motor is correct. If there is any abnormality, cut off the power in time and inspect it. The third part is the function description of the basic operation panel. Operation mode display. When the PU mode light is on, it indicates PU operation. When the EXT mode light is on, it indicates external operation. When the net mode light is on, it indicates network operation. Unit display. When the HC light is on, it displays the frequency. When the A light is on, it displays the current. When displaying the voltage, the light is off, and it flashes when monitoring the set frequency. Monitor. For digit LED, it can display information such as the frequency and parameter number, providing intuitive feedback for the operation. M knob. It is used to change the frequency setting and parameter setting value. It can display the set frequency in the monitoring mode, the current setting value during calibration, and the sequence in the error history mode. Mode switch. Switch the setting mode. Pressing it together with the PU key can switch the operation mode, and pressing it for 2 seconds can lock the operation. Set confirmation of each setting. Pressing this key during operation can display the running frequency, output current, and output voltage in sequence, which is convenient for real-time monitoring. Operation status and parameter setting. Operation status display. When running forward, the light flashes slowly in a 1.4 second cycle. And when running in reverse, it flashes quickly in a 0.2 second cycle. It flashes when it cannot run, or the frequency command is lower than the starting frequency, or when the MRS signal is input. Parameter setting mode display. The light is on when entering the parameter setting mode, which is convenient for detailed parameter adjustment. Stop operation. It can realize the alarm reset and ensure the safe stop of the equipment. The fourth part is the parameter setting method. Restore the parameters to the factory default values. After turning on the power, press the PU key to enter the PU operation mode. Press the mode key to enter the parameter setting mode. Set the parameter number to ALLC. Press the set key to read the current setting value. Then set it to 1, and press the set key to confirm. Notes. After restoring the factory default values, all parameters will be restored to the default settings, and the key parameters need to be readjusted to meet the actual requirements. Change the parameter setting value. After turning on the power, press the PU key to enter the PU operation mode. Press the mode key to enter the parameter setting mode. Set the parameter number to P1. Press the set key to read the current setting value. Then set it to 50.00 Hz, and press the set key to confirm. Application scenarios. Adjust the frequency parameters according to the actual working conditions to optimize the operation efficiency and performance of the equipment. Now let's take a look at the actual operation. This is the actual frequency converter. The wiring of the actual frequency converter. 1 grounding wire, 6 main current wires, and 6 control signal wires. Let's start explaining the connection of the frequency converter. This is an empty frequency converter, and the wires have been removed. We are using the Mitsubishi S1117 frequency converter. The function of the frequency converter is to be able to randomly adjust the rotational speed of the AC motor according to the work needs, playing a regulating role. First of all, before wiring, the frequency converter has been installed here, and the panel cover needs to be opened. There is a buckle at the bottom of the panel, and you can open it by pulling it outwards. There are many wires here, and there are 7 main wires. First, connect the grounding wire and connect the grounding wire to the ID terminal. Then connect the main incoming wires of the frequency converter, that is, the 3 terminals L1, L2, and L3. These 3 wires come from the main power supply of the frequency converter and are L41, L42, and L43. Connect L41 to the first terminal. The 3 wires L41, L42, and L43 have been connected. The other 3 terminals are the UVW output terminals, that is, U, V, and W, which are connected to the AC motor. Pay attention not to connect the wires in the wrong order, and connect them in the order of U, V, and W. Currently, only the strong current part has been connected. Some other control circuits are connected through this row of terminals. A total of 5 terminals are used here, which are the forward rotation, reverse rotation, medium speed, low speed, and stop signals of the motor. These signals all come from the PLC, and there is also a 0-volt terminal. First, connect Q0.2. Connect Q0.5 for the low-speed operation of the motor to the second terminal, and use a small rotary screwdriver for wiring. Connect Q0.6 to the medium speed and use the third terminal. Connect Q1.0 to the stop signal and use the fifth terminal. Connect Q0.4 to the forward rotation signal of the motor and use the ninth terminal. Connect Q1.6 to the reverse rotation signal of the motor and use the 10th terminal. Connect the last terminal to 0 volt, and connect all the signals back to the common 0 volt terminal. Check after connection. Q0.5 is connected to the second terminal. Q0.6 is connected to the third terminal. Q1.0 is connected to the fifth terminal. Q0.4 is connected to the ninth terminal. Q1.6 is connected to the 10th terminal. And the last terminal is connected to 0 volt. In the front are the L41, L42, L43, U, V, W, and grounding terminals. After connecting well, cover the lid. The parameter setting can be carried out through the LED screen and buttons: mode, set, pull, long stop on the frequency converter, and signals such as the frequency and current can be displayed. Finally, check the wiring. This is the result of the connection. The buttons on the touchscreen are used for operation. For the parameter adjustment part, it is carried out according to the product instruction manual of the manufacturer. Generally, it has been set well and does not need to be adjusted. If it is a new device, the parameters need to be adjusted according to the instruction manual. The panel of the frequency converter. Now let's explain the function introduction of the basic operation panel of this frequency converter. First, look at this frequency converter. Its panel is composed of a digital display, that is, a digital display screen, 5 buttons, and a knob. First, look at the screen run button. After we set all the parameters, pressing this run key can start the motor. Then this red stop key is used to stop the operation of the motor. We can press the stop key during the starting process of the motor, and it can stop the motor. On the far left, there is a knob. The function of this knob is that when setting some parameters, for example, if the parameter is the current, we can change the magnitude of the current through this knob. This is the function of the knob key. There are 3 white buttons below. The first one is the mode key, which is used to switch functions. Pressing the set key can realize the function of setting parameters. The last PU key is used to switch between the PU and EST modes. Now let's power on and give an introduction to the power on. Okay, it has been powered on now, and we can see that the digital display screen of the frequency converter is on. First, look at this digital display screen, which is used to display the current parameters of the motor. We can see that there is a Hertz mark on the right. When this Hertz mark lights up, the content currently displayed is the magnitude of the frequency. Then we press the set key, and it will transit to the mark lighting up. When the mark lights up, it means that the parameter displayed in the digital tube represents the magnitude of the current. We press the set key again. When neither the Hertz mark nor the mark is on, the content displayed in the digital tube is the rated voltage parameter. Press the set key again, and it will return to the initial state. Now let's introduce the functions of these 6 indicators on the panel. First, this is run indicator. When the motor is started, it will light up, indicating that the motor is in the running state. Then this MON is the monitoring indicator. When the MON indicator is on, the running state of the motor can be monitored. Then this is the PRM indicator. When the PRM indicator is on, it means that we are setting parameters. Then when this PU indicator is on, it means that the current operation mode is the PU mode. When the EST indicator is on, it means that the mode is the EST mode. Then the net is the network operation mode. Now we want to start the motor at a frequency of 50 Hz and see how to set the frequency. First, press the mod key, and you can see that the mode has been switched. We switch P0 to P1. P1 is the corresponding position for setting the frequency. Then after we switch to P1, press the set key, and it will enter the frequency setting. We can see that the current frequency is 30 Hz, and we need to switch it to the parameter of 50 Hz for operation. Then we can adjust the parameter magnitude through the knob. Turn the knob clockwise to set the frequency to 50 Hz. Okay, now the frequency has been set to 50 Hz. After the setting is completed, press the set key to save the parameters. Okay, after pressing it, you can see that it is flashing between 50 Hz and P1. During the flashing process, press the mode key, and it will display a 1, which means that the setting is completed and it exits the setting state. Press the mod key again to return to the initial panel. So far, the frequency has been set. Let's do an experiment. Press the start button and see if the motor can run at a frequency of 50 Hz. Okay, press the run key, and we can see that the motor has been started now. Then the frequency is also increasing continuously. During the rising process, press the set key, and you can see that the current information is between 0.53 and 0.54. Press the download again, and you can see that the current rated voltage is also changing continuously. After pressing the download again, it returns to the initial state. We can see that now the motor has reached a frequency of 50 Hz, which means that it is now running at the rated power. Okay, next we press the stop key to stop the operation of the motor. Press the stop key, and now the motor has entered the deceleration state. Finally, when the Hertz reaches 0, it enters the stop state. So our demonstration ends here. Finally, please think about this course and complete the following exercises, aiming at consolidating the knowledge points you have learned today and further deepening your understanding. This lesson ends here. See you next time.